Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Can you tell me how to use open source model integration with DSPy? This is one of the quintessential questions that will come, and whenever it is going to be our language model, there is a cost involved, whether it is going to connecting with closed source or open source. Yep, you heard me right. Even if you are going to connect with open source models, you still have the infrastructure cost like GPU and the hardware that you are going to require for connecting with the GPU. When it is going to be closed source, yeah, the API costs by default is there. But apart from that, there is also the fine-tuning cost and also how to collect the data, working with the data, storing it. So there are various kinds of costs involved, and there is a process that needs to be done. In this discussion, we are going to see how you can configure language models in DSPy, not just OpenAI. So we are going to take a look at HuggingFace models as well as Ollama models. If you guys are new to both HuggingFace and Ollama, I would suggest to take a look at the videos that I have already attached in this particular video, and also in the description I would have given the links also. You can take a look at that. Ollama is an application that allows you to serve the large language models, and HuggingFace is an open source ecosystem where all the open source models are hosted, and whenever you want, you can actually pull the models, load it in your local environment, and you can do the inferencing. I'm just giving you an overview, but there is an entire playlist, in fact, on in my channel regarding this HuggingFace Hub, the various tasks it can follow. In fact, just give me a second. I have created a kind of a Streamlit application that is hosted in the spaces, HuggingFace spaces, where I discuss about the various model architectures, the different types of the decoder-encoder architecture, and the various domains in AI, NLP, and not just that. I also list the various models that has been already developed in the various domains. So if you click on computer vision, you will see the various models that has been developed in the encoder, decoder, and convolution type of models. If you click on NLP, you will also see similar kind of updates in various kinds of different kinds of models. And as you scroll down, you will see the various kinds of tokenizer algorithms. And as you scroll down, you will also see how you can use the tokenizers. So this particular application provides you an overview of the various NLP, various large language models, not just large language models, even the neural networks, both vision as well as NLP, and also it discusses about the various architectures and also various ways you can use the tokenizers. And finally, it also talks about the various tasks that you can perform inside using the NLP models and the architectures that you can use for it. So if you scroll down, you will see the various architectures that you can use for an example, let us say text classification. Inside text classification, you can use these models, and then you can look at the ways you can use the model that is best used by most of these applications shared here, and the class in HuggingFace transformers that you can use for loading this. All of these things has been shared here. The idea of discussing the overview and showing you that Transformers Universe application is to give you a image of what you can do with open source. So, but DSPy process makes it fine-tuning, working with the prompts with open source models way more easier than it is possible, because as of now, if you have been following this series of videos, this is the second video. I have not delved into the optimizer part or the way to evaluate the models. It is still a little more farther away from this discussion. But once you look at the evaluate process, once you look at how the prompt is getting modified, then you will understand that the power of programmatically modifying the prompts. So second thing is that LM can be fine-tuned with DSP objects, and we can also learn. So as you as you just now saw, by introducing Hugging Face clients and Ollama clients, I was able to tell you about the Hugging Face entire tasks and options that is available in Hugging Face Hub to use the open source models, and also Ollama application, the video is separately created, so you can take a look at that. Fine. We have seen the introduction, we have seen the benefits of working with open source models and DSPy. Next, what you're going to do is we are going to first start by loading the environmental variables. I have this OpenAI API key inside this .env file, so that's why I'm loading it, and I am instantiating the OpenAI library also. So let me start doing that. So I've started the process, and then I am going to call these classes. So I'm going to call OllamaLocal, HFModel, predict, signature, settings, and context. So these are the classes that I'm going to call from DSPy. And you must be seeing this is a little bit different from what you see in the DSPy tutorial. The reason I'm using this method is that once you know exactly what kind of classes you are going to use, you will also understand the purpose very clearly. And this is something that I found as I was trying to find ways to remember stuff. So this was making it easier. So to know from which module what class I'm importing, that will actually make you to remember what is the purpose of it, how to use it, and where it was used last. So all these things you can remember. In order to instantiate the OpenAI model, all you need to do is call the OpenAI class with the model name, and then I have to configure it as lm equal to turbo. So settings.configure. So it is that simple. Okay, I'm going to start this. I am going to run that cell, and I'm going to run this cell. So now it has been configured. Once that language model has been configured, that is the next class that we are going to use, that is called as predict. So this predict class will use the signature, question and answer. So we are going to use multiple language models in this particular notebook, and we are going to see how they respond, but we will be using only single predict class. So this is the beauty of programmatically accessing and working with language models. 3 language models or 4 language models that we will be working with, and we will be using this particular single predict object that is created from this predict class. That's what we will use, and I'm going to execute this. So it has been executed, and now it starts. So here this is something that you'll see new in this video. So we'll be using something called as context with context, and in the context I am actually giving the large language model, and under the context I am calling this predict QA. That is the predict object that I created here. I am calling it under that. So what will happen is this predict object will use this language model and provide the output. And the question that I'm asking here is, who is the president of Indian subcontinent in 2007? So this is something in the past. I want to see whether the model is able to respond. I've already tested it. You can see the output here, but still I'm going to execute this, and I'm going to, okay, this is a mistake here. It should not be here. So let me remove that. I'm going to execute this, and you'll see that it is giving a correct answer, and we see the response is Manmohan Singh. And if you want to check something else, so who is the world fastest man and woman? So let us, why to leave any one gender? So who is the world fastest man and woman? So you can see the world fastest man is Usain Bolt from Jamaica, and the world fastest woman is Florence Griffith Joyner from the United States. So the model works and it gives a good output. Let's now come to the next step. In order to start working with the Ollama servers or Ollama models, you need to first of all have the Ollama models in your system. So for that you have to let me go back and show you the Ollama models that is available in my system. So Ollama list, if I do a Ollama list, you will see that I have 2 models, that is Gemma 2 billion and Mistral Q4 latest. Apart from this, Ollama service is already started. So how will I know that Ollama service is started? It's pretty simple. All I need to do is I have to go to AI controller, and I have to call AI controller at 11434. So AI controller is the name of the Linux machine that I am connecting with. and you will see that Ollama is running. If this output is not coming, or if this port is not connecting, then the server is not up. That is one way. Next, you can use the Ollama. So this is a just a crash course on Ollama. If I do Ollama run, and if I say Gemma 2 billion, Gemma 2 billion, and it will initiate the model and it will get ready to take the messages. So I can ask who is the fastest man and woman, and you can see that it is able to give me all the details. That is one thing. And now if I do the same thing with Mistral Q4, you can see that with Mistral Q4 we can do the same thing. So if I say Mistral Q4 and let me execute that, and let me ask the same question and see how well Mistral Q4 responds. Who is the fastest man and woman? And the answer seems to be correct, but also the format that it gives is a little different, and also in case of women the answer seems to be different actually. So in case of OpenAI and Gemma, the answer was okay, here it came Misty Copeland. Other notable fastest men and women, it's Griffith Joyner. So I think there is some kind of difference that is provided by each of the models. And anyway, so the idea here is how to get the output. Okay, and most of these open source models have their own way of hallucinations and their own way of modifying the data that I'm not going to discuss. I'm just trying to show you how to work with these models. In case of Ollama connection from DSPy, you need to use OllamaLocal and in local class, and you need to provide the model name. This model name should be same as the model name that is listed here. So this one. And in this case, you have to provide the full Gemma :2 billion, or else it will not work. So you need to provide that correctly. And then if you provide the model name here, you need to provide the model type. So if you take a look at this option here, you'll see that it has got lots of parameters. So you can provide the max tokens, you can provide the temperature, like everything that you can control in the open source model, it can be done here. So you can take a look at these things. I'm not diving into the parts and details of these parameters. Lot of literature is available. Just take a look at it, you will be able to find it out. But keep this in mind, by default the base URL is localhost 11434, and the default model type is text, and rest of the things you can see the default values here. If you go up and if you check the OpenAI model the same way, you'll see that OpenAI model has API key, API provider, API base, and model type. Similar to that, but it does not have the control for the top K, top P, temperature, etc. These things you can actually send it as key value args. That is also possible. This is something that I want you guys to understand. Let me execute this. So that is going to create me Mistral_Ollama object for Ollama model. After I do that, I need to again use the same context. I'm going to use the context, but this time it is going to be Mistral Ollama, and I'm going to call the same question: who is the world's fastest man and woman? And then let us take a look at the result. So now it is going to connect with the Mistral Ollama and try to provide me the answer. And to your surprise, it is not giving me an answer. So this is something that I saw when this is something that I found when I was working with Ollama models, and this is because of the signature that we are using. Okay, how the signature is affecting this, why it is not working, all these things we will look in the next video, where we will dive into the signatures. But as of now, you can take a look at that, it is not working. Anyway, now let us move to the Gemma 2 billion. So this is another model that I am starting from Ollama, and I am going to call Gemma Ollama and see the response. But to your surprise, the context does not provide any information about the world's fastest man and woman. So I cannot generate the requested fields. So even though when I tried to get the answers here, when I tried to use Gemma 2 billion, I got the answer inside the Ollama application. But when I am doing it here, it's not answering. So what is happening here? Why is this issue arising? This is because how we are calling the prediction. because in prediction we are actually sending the answer and we are asking for the question and the answer, right? And also we are telling to the we are also letting DSPy to create the prompts in the backend. So if you look at my earlier video, the first video in the series of playlist, you'll see how this predict is creating the automatically creating the prompts. So that is why you see all these things. These things can be understood and then corrected also. But the idea here is to show you how these things are different, right? Now we have seen OpenAI connectivity, creating connection to OpenAI, ChatGPT, GPT 3.5, GPT 4 models, and we saw how you can connect with Ollama servers. And then here we are going to connect with HF model, that is HuggingFace models, that is already downloaded to local machines. In my case, I already have Gemma 2 billion IT, that is instruction tuned model, in my local machine. So in order to connect with that HF model, all I need to do is call this HF model class and send this path. So I need to give the model path, not the path of the file location. So if I give the file location path, it will fail. So keep that in mind. This is going to load the model using the auto model class in HuggingFace. So I showed this here. So the auto model class here. So if you go and click on causal LM, it will take a second, it will update, and you'll see that it will use the causal LM class. So the same thing will be used here also in the backend. And if you go to this location, you'll see that almost 10 GB of GPU VRAM. So this is the GPU NVIDIA SMI output, and you can see almost 11 GB of GPU VRAM is getting consumed, because this Gemma 2 billion IT takes that much space, and there is no quantization involved. And by default, this model uses HF device map auto. So that's why the model loads and automatically into CUDA devices as well as your RAM also. You don't need to worry about that control. So it is taken care by this. And then you can use this same context and you can ask for the output. And here is where you see that the HF model actually tells and gives you the complete prompt also. And this is where the challenges must be very clear, because whenever you are trying to give this kind of a prompt to the various open source models which has different kind of the generation parameters. So there are something called as tokenizer parameters, generation parameters, and also chat templates. So these things are different for different models. Because of that, the answers from the model when it is connected to the DSPy is different. So let us actually check it. So if whatever I am telling is right, so then if I directly connect with Ollama model, so if I directly connect with HF, just a second, let me prompt Gemma Ollama. So this is something that I am doing without checking it, without actually previously testing it. So let us see. As of October, you see Gemma Ollama here told that who is the fastest man and woman in the world is a question, and the answer it doesn't know. But when I am directly prompting it, that is without predict, I'm directly prompting it, you see it is replying. The world's fastest man is Usain Bolt, and the world's fastest woman is Florence Griffith Joyner. So why this is actually not working? So when I'm using predict QA, there is no answer. But when I am directly connecting to the model and prompting it, there is answer. So the culprit is the way we use this predict QA object and the internal prompt this predict QA has. This is how you try to understand the root cause and then learn from the various modification that the prompt creates. Prompt is very important. And the more you understand how to automate the prompt creation and modify the prompt creation, that we will discuss in this near future, you will become better and more efficient in managing the large language models. Let us proceed further. So finally, we can ask for more outputs from the model also. So for that, we need to use this n equal to 2 or the n parameter, n argument in the predict class. So if you do that, then whenever you call for the prediction, that many predictions will be requested. So you'll see that now I'm getting 2 predictions from OpenAI turbo model, and I'm using the simple for loop to enumerate, and I'm printing it. So by now you must have understood the overall process, I suppose. Apart from these clients that I already shown, the OllamaLocal, the HF client, and also the OpenAI that we already saw, there is HF client TGI, HF client VLLM, and chat module client. So these clients, I would like you guys to explore it yourself, and you will be able to use them in your if you have those models located there. Let us do a recap. So I hope that you understood a thing or two from this discussion. We already saw how you can connect open source models with DSPy, and why connecting with the DSPy and the open source model matters a lot. How the prompt impacts the open source as well as the OpenAI models, how they answer, how they compare, and how we are using the context function with context in using the prediction. We have seen all these ideas in this discussion. So I believe that you can do a lot of experiment with this now with your own devices, and if you have a GPU, then it's well and good. You can start working with that. With that said, I would like to leave with 4 words, that is practice, 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 practice. See you guys. Have a great time.